Hello, I'm going to show you how to solve this week's MCA practice problems. Our first one is dividing fractions. So there's a couple things we need to do before we divide these fractions. First, we need to convert to an improper fraction. Then we have to flip the second and multiply. So we know that is how we divide fractions. Then we convert the answer back to a mixed number. So I'm going to make that a little bit smaller, but those are our steps there. So first, converting to an improper fraction. We have 1 and 1/10. So we can imagine that over here, this 1 represents 10 tenths, because it's 1 whole. And then we have 1 more over here. So there is 10 tenths plus 1/10. That means we have 11 tenths. Over here, we have a similar situation. Instead, we have fifths. So this 1 can mean 5/5. So there's 5/5 and 1 over here. Put that together, that is 6/5. But we need to flip the second and multiply. So when we're dividing 11 tenths by 6/5, we're going to flip these over. And instead we're going to have 11 tenths times 5/6. So I'm going to show you something that we did not talk about in class, but will help you when you are solving fraction problems. We can take these and put them together and simplify before we multiply. Because really, this is just one big fraction. We have 11 times 5 up here, 10 times 6 down here. And I see this 5 here and this 10 over here, and I can reduce those before we multiply. So I'm going to say instead of 5/10, I know that 5/10 is the same as 1/2. So I'm just going to change it to 1/2. Put a 1 over here and a 2 over here. And you're going to get the same answer because 5/10 and 1/2 are equivalent fractions. They mean the same quantity. Now, when we go to multiply, it's a lot easier. We get 11 times 1 is 11 over 2 times 6, which is 12. And that is one of our choices, 11/12. Now, if you didn't know you could reduce, you could reduce afterward. If you have 55 divided by 60, you know that these two numbers are both divisible by 5. So if we take 55 divided by 5, we get 11. And if we take 65 divided by 5, we get 12. So we get the same answer, 11/12. Well, on the next problem, we are being asked to do the prime factorization of 630. Now, the best way for me to do this, you can do it a different way, but the way that makes sense to me is to draw a factor tree. So I'm going to think of numbers that multiply up to 630. Well, I know because this ends in 0 that it is a multiple of 10. 10 is a factor of 630 because 63 times 10 makes 630. Whenever you multiply by 10, you're just adding zeros to things. So now I can break this down further. What are some numbers that multiply up to 10? Well, I got 5. I've got 2. Okay. Can those be broken up anymore? No. You can't divide 5 or 2 by anything else. So those are prime numbers. Now I can look over at 63. 63, I know, can be divided into 9 and 7. 9 times 7 is 63. So 7 is a prime number. So we can leave that one there. And then we have this 9. 9 can be divided into 3 times 3. And those are prime numbers. So if we write out all of the prime numbers in order from smallest to biggest, we get 2 times 3 times another 3 times 5 times 7. And if you double checked and put all of this into a calculator, it would multiply up to 630. All right. And the last one. We have a lot going on here, so I'm going to break this down into a few different steps because we know we have to follow PEMDAS. All right. So the first part of PEMDAS here, the parentheses and exponents. We don't have any exponents, but we do have parentheses. So I'm going to solve that part first. And I'm going to switch colors over here. I'm going to bring this problem over here. We have 1/2 plus 3/8. When we're adding fractions, we need to have the same denominator. So we can't just add 1/2 plus 3/8. We need to find a common denominator. So if you start listing out the multiples of 2, you get 2, 4, 6, 8. So we don't have to change the 3/8, but we can change 1/2. We know that 2 times 4 is 8. So 1 times 4 is 4. 4/8 is equivalent to 1/2. And now we can add. 4/8 plus 3/8 gives us 7/8. Well, now knowing that, I'm going to rewrite the problem. We have a 4. We have 7/8. We have a minus sign, and then 5/8 times, a dot means times, 2. So the next part of PEMDAS is multiplication and division. We don't have division, but we do have some multiplication. We have the multiplication right here, and we have multiplication right here. Whenever you have a number next to parentheses, it is implied that you are multiplying whatever's on the outside by whatever's on the inside. So let's break these out. We have 4 times 7/8. So we can put 4 over 1 times 7 over 8. And if we do the reducing, well, let's not do the reducing. We're going to do 4 times 7. We get 28. And then 1 times 8 is 8. So we've got that. Now, we're going to do this one. 5/8 times 2 over 1. Now we have 10/8. eighths. We're going to rewrite this problem again. New color. Let's go for green. Now we have 28 eighths minus 10 eighths. We can do that. 28 minus 10 is 18. And the eighths stay the same because we're subtracting. 18 eighths. We've simplified, right? Well, 18 eighths is not one of our choices. So we have to take this and simplify it more. We have to turn it into a mixed number and make sure it is simplified all the way down. So to do that, we need to think about how many eighths we have here. If there's 18 of them, I think, okay, well, 8 of those eighths can make one whole. And then we have another 8 eighths to make another whole. And that would give us 16. So then we're going to have 2 left over. So 18 eighths is the same as 2 and 2 eighths, which is, again, not one of our choices. So we're going to have to reduce further to 2, and 2 eighths is equivalent to 1/4. 2 divided by 2 is 1. 8 divided by 2 is 4. So our final answer is 2 1/4.